All right, for this next question, the big idea is prime numbers. A prime number is a number that only has two factors, one and itself. Also, there's a strategy we could apply with divisibility rules. We'll get to that a little bit later. But let's check out this last one, see if this is a list of only prime numbers. Now, to get 11, the factors are 1 and 11, because 1 times 11 is 11. But is there another set of factors of 11? The answer is no. The only factors of 11 are 1 and 11, so 11 is a prime number. What about 17? We know that 1 times 17 is 17, so 1 and 17 are factors of 17. But are there any other factors? No, 17 is a prime number. All right, 37. You could do 1 times 37. Are there any other factors? I don't think there are. I think 37 is a prime number. For 39, we could do 1 times 39 to get 39. But are there any other factors of 39? So to think if there are any other factors, let's take a quick break and talk about divisibility rules. Okay, there are some divisibility rules that you probably already know. The easiest one is probably 10. For example, is 120 divisible by 10 evenly? The answer is yes, it is, because 10 is divisible to anything that ends in a 0. So any number that ends in a 0 is automatically divisible by 10, meaning that 10 is a factor of 120. Some other divisibility rules you're probably familiar with. The divisibility rule for 5 is 5 divisible into 335 evenly. Because it ends in a 5, the answer is yes. 5 is divisible into anything that ends in a 5 or a 0. So 5 is actually divisible into 120 as well. Another divisibility rule that you're probably familiar with, divisibility rule for 2, is 2 divisible into 846. I'm sorry, 864 I should say. So 2 is divisible into 864 because it's an even number. If any number is even, it's automatically divisible by 2, so yes. All right, now a divisibility rule you might not be familiar with is the one for 3. Okay, so how can you tell if a number like 348 is divisible by 3? And it turns out you do not look at the last number like we did for this or this or this. What you want to do is get the sum of the digits. What is 3 plus 4 plus 8? Add the digits together. So again, we're getting the sum of the digits, 3 plus 4 plus 8. That equals 15. Now, is 3 divisible into 15 evenly? Yes, it is. That means 3 is divisible into 348. Okay, that's important because that divisibility rule is going to help us specifically for this question. Okay, so let's go back to, are there any other factors for 39 other than 1 and 39? So let's check the divisibility rules we just talked about. Does it end in a 0? Because if so, we could divide it by 10. No. Does it end in a 5 or a 0? Because then we could divide it by 5. No. Is it an even number? Because then it's divisible by 2. No. All right, what is 3 plus 9? Let's add up the digits. So 3 plus 9 is 12. Is 12 divisible by 3? 12 is divisible by 3. That means 3 is divisible into 39. And even if we don't know the other number, we now prove that it has more than 2 factors. It's got 1, 39, and 3, and something else, which means it's not a prime number. Turns out, by the way, it's 3 times 13 that would equal 39. But using that divisibility rule for 3 proves that that is not a prime number, so this is not a list of all primes. Okay, so what about this list? Is this all primes? So 7, you could do 1 times 7. Check your divisibility rules, you'll find out 7 is a prime number. All right, so check these. I'll tell you this, that 3 of these are prime, but one of them is divisible by 3, just like 39 was divisible by 3. Can you find the one of these numbers here that's divisible by 3? Okay, so remember the rule is add up the digits. 9 plus 1 is 10. Is 10 divisible by 3? Nope. Is 19 a prime number? Yes, it is. 33. 3 plus 3 is 6. Does 3 divide into 6? Yes, it does. That means 3 divides into 33, which means this has more than 2 factors. It's got 1, 33, and 3, and also 11, because 3 times 11 is 33. So this is not a prime number. 41 is a prime number. All right, so look at these last two lists. One of them is only prime numbers. One of them, again, is divisible by 3 because of using that rule that we know for 3. So can you find the list that has only prime numbers in it? And can you find the one number that's divisible by 3, making it not prime? All right, so 7 is prime. 11 is prime. We already checked both of those. 7 plus 2 is 9. 3 divides into 9, and 3 also divides into 27. So this is divisible by 1, and 27, and 3, and another number. Turns out it's 9. And so that is not a prime number. 43 is a prime number. But it turns out in this list right here, all of these are prime numbers. So that's the answer we want. All of those are prime numbers. All right, so again, prime numbers only have 2 factors, one in themselves, and divisibility rules, things like we know it's divisible by 5 because it ends in a 0 or 5. We know it's divisible by 2 because it's even. And now there's a new divisibility rule, new for some of you, that if you add up the digits, you could see if that number is divisible by 3 or not.